Hello, this is a lecture over verifying identities. This is a section that very hard to teach because this is something you just have to do yourself. So when teachers usually teach this verifying identities, it's mostly just show you example, an example, an example, and it's just a matter of doing it yourself and getting good at it. And so I'm giving you a couple of problems here. I'm gonna give you one over here that you can't see off the camera right now that has a little bit of log and trig. So a little bit of algebra and trig put together. You'll see that when I move the camera over there. But these are a couple of problems that are in the book. And it's number 7 and number 28. They're in the book, Swakowski book. And so uh, what we're going to do is we're going to verify these identities just like we did back in chapter 5. And we're going to show the left side equals the right side. But if you recall that you can also show that the right side equals the left side. But if you look at this one, here's the left side and here's the right side. It's always easier to break something down into something smaller than going from smaller to larger. So this is definitely going to be easier to knock it down to this one. This one over here is a fraction, okay? And this one into this one, okay, or this one into this, I think it's going to probably be about the same. To go from left to right, you have to do a little bit of a trick. If you go from right to left, you got to use the reciprocal identities and then put them together, and hopefully something cancels out. But I still think the left side into the right side will actually be a little easier than this one, the other way. So what we're going to do is we're going to verify this side equals this side. And remember, a lot of trig at first, a little bit of algebra. So you're like, well, this is the same stuff that we did back in chapter 5. Yeah, but this is in chapter 6.1. This is actually putting it, all these sections together and giving you a full dose of verifying identity. So when you actually see the problems, this is 28, and I'm not even halfway there yet. So there's a lot of verifying identities in this section. And this is going to be a two-part lecture. 6.1 is going to be first part is going to be verifying identities, and then the next part is showing something that is not an identity. I'll show you how to do that in part 2 of this lecture, and doing some trig substitution. Okay, so let's keep this going here. So I'm going to put these two together. You always get a common denominator. That's what algebra says. So what I'm going to do is put this together. So we sine of 3u times 1 plus the cosine of 3u is the product of the two denominators. So this one right here, it needs the 1 plus cosine of 3u. You're like, well, it already has one. Well, it needs another one because this fraction has the 1 plus cosine of 3u in this denominator. So that needs to be squared. And this fraction has the 1 plus cosine of 3u. It's already there. But it needs the sine of 3u. So this one's going to be sine of 3u squared. So now we do a little bit more algebra. So this is going to be FOIL this one out and just rewrite this one. And you're going to notice something cancels out. So this is going to be 1 plus 2 cosine of 3u plus cosine squared of 3u, FOIL. And this was just sine squared of 3u. This is all over sine of 3u, so 1 plus cosine of 3u. So if you notice, really, I haven't really done much as far as trig is concerned. Most of it's algebra, and but now here comes some trig. Cosine squared of 3u plus sine squared of 3u, as you recall, that's one of your Pythagorean identities, and that's 1. And so this is 1 plus the 1 that's out front, so you can combine across terms. So 1 plus 1 is 2. And then 2 cosine of 3u just gets written down over sine of 3u times 1 plus cosine of 3u. Okay, now a little bit more algebra. Factor the 2 out. So it'll be 2 times 1 plus cosine of 3u over sine of 3u times 1 plus cosine of 3u. But there's a factor of 1 plus cosine of 3u on top and bottom. They cancel out, leaving me with 2 divided by the sine of 3u. And that's the same thing as 2 times 1 over sine of 3u. The reason I write it that way is because I want you to notice that these are actually two separate things, and then 1 over sine is the same thing as the cosecant. So this becomes 2 times the cosecant of 3u, and that is the right-hand side. So, but as I like telling you guys many times, when you're proving identities, there is not just one way of doing these things. And if you recall, my boxes mean that's the end of proof. Okay, so this one right here, the left side equals the right side. Took me 1, 2, 3, 4, 5, 6 steps. If you ask me to do this tomorrow, I might do it a different way. It's just the way my brain worked at the time I tried it. And you're going to have to just kind of get used to, sometimes you go down these rabbit trails and you get lost. And you just say, okay, I don't know what the next step is. So you go back and you start over again. So sometimes it takes several attempts to get to the problem. When I'm doing this on the board in class or here, you're seeing me after many years of practice with this stuff. When I first started this stuff, I wasn't as fast, I wasn't as quick, and I wasn't as good. There was a lot of times I had to go over and over again. So it takes a little bit of work. This doesn't happen overnight. If you don't practice proofs, you don't get good at proofs, period. So, all right, so this is number 28, okay? So sine over 1 minus the cosine of t equals the cosecant of t plus the cotangent of t. Now, whenever I see something that has one term on top and two terms on the bottom, I immediately multiply by, think about the conjugate of the bottom. So that's the conjugate, remember, is if it's a plus b, the conjugate is a minus b. It's not the opposite. Opposite would be negative 1 plus cosine of t. So opposite would be taking the opposite of both terms. The conjugate is opposite of just the second term. So this becomes the sine of t over 1 minus the cosine of t, without change, times 1 plus the cosine of t over 1 plus the cosine of t. And this is a little trick of the trade, but it works. So this is the sine of t times 1 plus the cosine of t. And if you FOIL the bottom out, that's 1 minus the cosine squared of t. And if you recall, that's the Pythagorean identity again for sine squared plus cosine squared equals 1, but just a different arrangement of the terms. So this becomes the sine of t times 1 plus the cosine of t over sine squared of t. And then one of these signs cancel. So it becomes 1 plus the cosine of t over the sine of t. And if you look around in the proofs, actually you will see another problem that you're trying to prove that the sine of t over 1 minus cosine is equals to 1 plus cosine over sine of t. So there's another problem within this homework assignments that this equals this. So a lot of times they duplicate their proofs. But in this case, we're not done. So what we do now is we got to get this equal to the cosecant plus the cotangent of t. And this is now, it's easy because now that you have a plus b over c, you have a fraction that's two terms on top that's separated by plus or minus. You can break them up. So this becomes 1 over sine of t plus the cosine of t over the sine of t. And now it should be easy pickings here for you. 1 over sine is the same thing as cosecant, and cosine over sine is one of your tangent identities, and that's your cotangent. The cosecant equals 1 over sine is one of your reciprocal identities. So this becomes cosecant of t plus the cotangent of t. And a lot of times I'm just lazy and I'll just write RHS, and as you could probably guess what that stands for, the right-hand side. So probably not the best formal way of doing it, but it's just an easy way to get out and get finished because you've done the meat of the problem already. So, all right. So these are a couple of typical problems in the proofs. Okay. Now this is the most of the ones you're going to see. Now I'm going to slide this camera over just a little bit so you can see my last problem over here. And as you can tell, it's going to look ugly at first, but you're going to find out that it's a lot easier than you think. So right here, we have the natural log of the cotangent of t equals negative natural log of tangent of t. At first glance, you think, oh my, that's going to be tough. But if you remember, cotangent is 1 over tangent. So the natural log of 1 over the tangent of t. Now, I can do this a couple of ways. I can apply the x 1 over x is equals to x to the negative 1 rule, or I can use the quotient rule. And most students understand the quotient rule better than the negative exponent rule, so that's what I'm going to use. So this is going to be the natural log of 1 minus the natural log of the tangent of t. And what I just did was the quotient rule for logarithms. If you recall that if you have a natural log of a divided by b, that is the same thing as the natural log of a minus the natural log of b. That's exactly the rule. That's what the quotient rule is stating. So that's what I just used. And I also recall that the natural log of 1 is equals to 0 because e to the 0 is 1. Recall that's one of your properties of logarithms. So the natural log of 1 is 0 minus the natural log of the tangent of t, and that is a negative natural log of the tangent t. If you just get rid of that 0 that's hanging out front that you don't even need. And that is the right-hand side. So at first, when you see this, sometimes the problems that look hard is actually easy, and sometimes when the problems look easy, they're actually hard. So you can't just do it by first glance. So, but as soon as you saw ln and trig function put together, your defenses come up and say, "Oh my, this is going to be tough." But if you notice, it only took me 3 or 4 steps, and sometimes they take 1, 2, 3, 4, 5, 6 steps, and this one took 1, 2, 3, 4, 5, 6 steps. So just because a problem looks tough doesn't mean it actually is tough. Just because a problem looks easy, it doesn't mean it is easy. And sometimes you can do a proof that takes you 12 steps and takes somebody else 8 steps. So I've had students who approve a proof in less steps than I, and there's nothing wrong with their proof. So they just saw a quicker way of doing it than I did. And like I said, you ask me to do a problem proof one day, I'll do it that way. Chances are I might find a different way the next day. It's just the way you're thinking at the time. It's a good thing about proofs. There's not always just one way of doing it. Some people don't like that because they think there's always should be one road to get to the destination. Proofs don't work that way. Sometimes you got several ways to get to the same place. So you just got to get past that. So, but anyway, these are just 3 typical proofs in 6.1. And the next part is going to be on 6.1 is going to deal with showing me something that is not an identity. And then I'm going to show you some trig substitution type problems. So hang tight.